I'm Anil Kumar, and with the help of this video, we will understand what does it mean by saying solve a trigonometric equation or find angle in radians. It seems from the request I get that these are the points which sometimes students are very confused about. If the question is solve the following in the domain 0 to 2 pi, solve the following really means you have to solve an equation as given. Find the value of angle, which in this case is theta in my example, right? So you need to find the value of theta, which will make cosine theta is equal to square root 3 over 2 for example 1. In example 2, you need to find theta, where sine theta will make square root 2 over 2. And in example C, tan theta should be equal to 0.75. You need to find all the valid values of theta. Now when we say domain 0 to 2 pi, we are considering one full circle counterclockwise, right? So angle here is 0, here it is pi, and then when you go all around this, then one circle is 2 pi. So in all these four quadrants, you need to figure out what are the valid solutions of the given equation. You can also remember that all are positive in quadrant 1, sine is positive in quadrant 2, tan is positive in quadrant 3, and cosine is positive in quadrant 4. So that helps, right? So some people remember this as a caste rule. Some say all students take calculus or all silver teacup. Either way you remember, but that is what it is. So I hope the point is very clear. So we need to find angle in radians since the domain is given in radians 0 to 2 pi, right? So that is what really the question is. Now I've taken simple examples but a very important concept. So let's begin by solving these three equations. First one is cos of theta equals to square root 3 over 2. So when this is given to you and the domain is 0 to 2 pi, you need to figure out in which quadrant we are working. Cosine is positive in quadrant 1 since all are positive, and in quadrant 4. So we are expecting two different solutions, right? So this is the first part. Second part is how could you find theta? One way is, of course, when you are given this equation, you can say angle theta is equals to cos inverse of square root 3 over 2, right? So you can do that. Use calculator. When you use calculator, make sure it is in radians, right? The other way to solve this is you can use special triangles, which you have learned, right? Special triangle for square root 3 over 2 could be drawn like this. This angle, consider pi by 3, that means 60 degrees, right? So the sides are 1 to square root 3. So you could use special triangle. From the special triangle, we actually always get acute angle. That is the angle in first quadrant. Pi by 3 is the angle on one side. The other side angle will be pi by 6. This is your, you can say 30, 60, 90 or pi by 3, pi by 6, pi by 2 triangle. Now, you want cosine to be square root 3 over 2. Cos, you know, is adjacent over hypotenuse, right? So cosine is adjacent over hypotenuse. That means we are looking from this side. That is the adjacent side, square root 3 over 2. So clearly the angle is pi by 6. So what we get from here as angle theta equals to pi by 6. So that is how we get our answer. And this answer is for quadrant 1. So we say, well, quadrant 1, the angle is pi by 6. It's kind of like this. So that is the answer we got, pi by 6. Now you know cosine is also positive in quadrant 2. So the second answer should be this one, right? That acute angle pi by 6 is going to give me cos positive. Now you have to always write principal angle. Principal angle will be counterclockwise coming to this terminal arm, which is indeed equal to, let me write that angle. So that angle theta is 2 pi minus pi by 6. You get the point, right? 2 pi minus pi by 6, right? So if you divide this into pi by 6 and pi by 6, it will be 12 sections. So this becomes 11 pi by 6, which 12 minus 1, 11 pi by 6, right? And therefore, we get two solutions for here. So we can write down our answer as theta equals to pi by 6 and 11 pi by 6. Do you see that? So these are the two solutions for the given equations, and these solutions are in radians. That is what we mean when we say how to find angle in radians. And domain 0 to 2 pi, so all the possible solutions. I hope you got the point. So now you can pause the video, answer the next question. That should be a good practice. Let us follow all these steps once again. So first thing, check out the quadrant. Sign is positive in quadrant 1 and in quadrant 2, right? So 1 and 2. Now we are looking for angle theta. So that sine theta is square root 2 over 2. So angle theta is sine inverse of square root 2 over 2. And if you use your special triangle, which is 45 degrees, or pi by 4 triangle, that gives you this answer, right? So where if this angle is pi by 4, right, that is 90 degrees for you, then these sides are square root 2, and 2. So theta in the first quadrant will be pi by 4. So that means this. That is pi by 4. And second is terminal arm could be in quadrant 2. So we have two solutions for theta. Let's say theta equals to pi by 4. That is the acute angle, pi by 4. The other one will be how much? The other one is this much. That is pi minus pi by 4. That is what it is, correct? So the other answer is, or theta equals to pi minus pi by 4, correct? So that gives you two solutions. And we say our answer is theta. The principal angle could be pi by 4. And it could be 4 minus 1, 3 pi by 4. Do you get the idea? So that is how we get all possible answers in radians for the given equation, right? Now the next example, purposely I have taken a number where you cannot use special triangles, right? So we will use calculator in this particular case, right? Now steps are exactly same. Now when is tan positive? Tan is positive in quadrant 1, all are positive here, and in quadrant 3, right? There you see. So we are looking for two solutions. So let us find the acute angle first. So it's a good idea sometimes. What we say is, we say let us find acute angle. So let's say this angle, acute angle B, let us say beta. We just give it a name, right? You could say alpha, beta, whatever you want, right? So we say let's solve for tan beta equals to 0.75. We say beta equals to, that is angle beta equals to tan inverse of 0.75, right? Now let us use the calculator. First step is you should change the mode so that you are in radians. For me, option 4 gives me radians. Now shift tan inverse and 0.75 bracket close equal to gives me that angle. So this angle for me is 0.64. Let's say we round it to 2 decimal places, correct? So we have that one answer, 0.64 radians. If I don't write any unit, it means radians, right? So because radians is a ratio. So the other solution should be in quadrant 3. So it would be a kind of straight line. So we have already got one solution, that is 0.64. The other one here is also 0.64 acute angle. But what is the principal angle? That is what we need to write in the solution. Principal angle here is theta pi plus 0.64, correct? So what we get for theta is 1, theta equals to 0.64, and the other value is, it is 0.64 plus pi. So let's add pi to this. So plus pi is equal to 3 point. So we get our answer as theta equals to 0.64 and 3.7. Let me write 985. I'm rounding it to 9s, right? These are all radians. You may or may not write radians here. But if you write angle without degree, it means radians by default. So if it is in degrees, you have to mention degrees, right? So I hope now these steps are absolutely clear. As a practice question, what you can do is, you can find angle theta for sine theta equals to, let us say, we are taking positive values in this video. Next video, I'll consider the negative values and find theta. Okay, that should be a good practice, right? 0. Let's say 25, and let me write this as tan theta equals to 1, and here I'll write cos theta equals to square root 2 over 2, right? So let us say these are your practice questions. You can follow the same process, get the answer for these ones. I hope that really helps. Thank you and all the best.